Okay, welcome everyone. Welcome to this webinar on AWS IoT Analytics. So, in terms of the agenda for this afternoon is on focused on IoT Analytics, which is a new service which we launched last week. But before we actually take a deeper dive into IoT Analytics, we'll actually cover some high-level overview of AWS IoT services as well. So for some of you who may not have enough context around AWS IoT services, we'll cover some of the basics as well. And then the idea is to give you kind of a dive into the IoT analytics, specifically look at what are the core components of the service. We'll touch upon some use cases as well, some common use cases around industrial IoT, consumer IoT use cases, and then I also want to spend some time on the kind of hands-on walkthrough of the service on the console itself, so you can get some idea about how to get started with IoT analytics. So before I go further, very quickly, just to introduce myself, my name is Niraj Kumar. I'm an enterprise solutions architect at AWS, based here in the UK. Okay, so let's move on. So before we actually talk about the IoT services, let's just try and understand, conceptually, how we think of IoT. I think from our perspective, we kind of see this as three pillars to IoT IoT use cases or IoT workloads. On one end, we have things. So these are the actual physical things such as sensors, actuators, the devices which are out in the field or in customers' homes. On the other end, you have cloud. So this is where our cloud-based services run, which really provides you a secure and scalable storage and compute capabilities for you to actually bring this data into cloud, so you can actually start, processing that data. And the third and the most important pillar in IoT is around intelligence. The reason you want to capture all this data so you can actually do run some intelligence on top of that, drive some insight from this data, whether it's the real-time use cases or predictive use cases. So you get a better view of what's happening in the physical IoT world, and sort of bring the digital information and try and analyze that with the storage and compute capabilities which are available in the cloud. And intelligence can work both on the edge as well as in the cloud, and we'll talk about this in a little bit more detail later on. Now, if you attended the previous previous webinar that we ran, my colleague Jan Machner ran, then you may have seen some of the edge use cases. So I won't dwell too much on the edge, things like green grass and FreeRTOS. But if you have missed it, I'm sure that'll be available later on. But today we're going to talk more on the cloud side of the story, so specifically around the analytics in the cloud. So on the cloud, back in 2015, we had launched AWS IoT service, and this was really our approach to enable IoT devices to be able to connect to the cloud, so you can actually securely authenticate these devices, and using the IoT broker component, you can bring this data into cloud. And then there are some other features within IoT core around device shadows, rules engines, that helps you not only bring this data, but also be able to control these devices in the field. Now, since then, we last year we had launched also another service called Greengrass. As I said earlier, this was covered in much more depth in the previous webinar. So, but for those of you who did not attend, Greengrass is basically, think of this as taking our IoT capabilities in the cloud, and that you can now deploy on the edge devices. So it gives you local IoT broker. It gives you ability to bring Lambda functions and run those Lambda functions on the edge devices. And similar concept with the device gateways. and similar security model that we have in the cloud, you can extend this into on the edge devices. So Greengrass has really enabled certain use cases, where you do not have kind of constant connectivity with the network, or where you may not be able to have intermittent connectivity, or where you want to make some very quick decisions where you can't actually depend on the latency. So whether it's car as one of the example, automated cars, where you want to actually make some very quick decisions within that local device network. So Greengrass is really addressing those kind of use cases. But since then, we have announced and now launched some new services as well. So back in reInvent a few months ago, so we have services around device management. This is where you can do a very quick way to onboard your devices on AWS IoT platform. Also helps you manage these devices, or the fleet of your devices. If when you want to update the software on these devices, or push the firmware and software like that, so you can actually do that through device management. We also announced a device security service called Device Defender, which will, when it's available, will help you do things like anomaly detection on your devices. If these devices are communicating at a port or at sources where they shouldn't, so it'll monitor these devices on the edge itself. And also back in reInvent, we had announced this new IoT Analytics service, which last week we have now launched, which is really the key focus of this webinar. So we'll go in more depth on IoT Analytics. So what is IoT Analytics? It's a fully managed service which allows you to collect, process, enrich your data sets. So by enrichment, we mean you can bring some contextual data from other sources, to make sense out of the IoT data stream. It helps you store. So the store, again, we'll look into these components in a bit more detail. It's a IoT optimized data store, all part of the same managed service. And then you can build your analytical use cases on top with integration with services like QuickSight when you want to visualize this data, or even SageMaker, which is our machine learning service. Again, we'll go into more depth on that as well. So why is it important? Why did we actually come up with the service? So these are some of the things we've been hearing from our customers, that as part of IoT use cases, especially when you start scaling your IoT devices, then there are a few challenges that comes up from analysis point of view. So typically IoT data is in high volume. Sometimes you can have sparse information in that data set, or it could be highly unstructured. It may come from multiple sources in multiple locations, multiple geographies. So you may not necessarily at times have a common metric even, so for example, you have temperature sensor deployed in different locations, different geographies. You may be getting something in Celsius, something in Fahrenheit. So it can be very highly unstructured and very noisy data that we often get from IoT devices. And also, when you look at the raw data coming in from IoT devices without an additional context around that, then it also becomes of very little value. For example, you're getting some data from sensors. If you can correlate that with other data sources such as weather, for example, or some other additional APIs or geo-specific data you may want to include in terms of the additional contextual data, then you can make more sense out of that data. So that's another thing that happens with IoT data. So IoT analytics, it provides in terms of the core capabilities. From the moment you get data into IoT analytics, it will enable you to filter the data. You can do some transformation on that data. There's some inbuilt transformation, which we'll look into in a few minutes. Or you can enrich the data from by invoking other services such as Lambda, or even using sources like the registry within IoT Core or device shadow, for example. It also provides you the ability to store raw as well as processed data. So before data goes into the pipe stream, into the pipeline, which we'll look into a bit later, you can actually store everything which is coming in, and you'll be able to also apply policies. You can keep this data for raw data forever, or you can apply some retention policies, as well as the processed data. Once it goes through all the filtering, processing, and transformation, then you can also keep that structured data sets for later on querying and building analytical viewpoints on top of that. So here's a high-level representation of what happens in the IoT analytics. So you can have data coming in from IoT things, or it can come from other sources as well. So if it's coming from IoT devices, which are using AWS IoT platform, the IoT Core service, then it has a native integration with IoT Core, which I'll show you on console. How it works is very simple. Using the rules engine, if you're familiar with the IoT Core service, using the rule engine, you can actually route all incoming telemetry or data you're getting from devices into something called channels. So channel is basically an entry point into IoT analytics service. You can create multiple channels, if you want to have multiple sources coming through different channels. And as well as IoT Core, you can also bring some, if you want data from S3 and say for Kinesis, or maybe other sources as well, using the APIs, IoT analytics APIs that we expose, so you can directly ingest into these channels other than IoT Core. Of course, there's as I said, native integration with the rules engine in the IoT Core. When this data arrives in the channel, it goes through the pipeline, which you can define, again, based on your use case. You can define a step-by-step process of how this data is going to go through the filtering, transformation, enrichment, and you can define that in multiple steps or one step, again, depending on the complexity around your on your transformation, specific transformation that you're going trying to apply. And once that data is processed, it is pushed into data store. It's, as I said, it's a IoT optimized data store. It's a time series data store, so it makes all the time series based queries quite fast. And from that data store, then you can create data sets. You can create multiple data sets. It's using the SQL query language. You can create multiple data sets if you want to create, say, for example, different views or different segment of your data. And once you have data set, then you can expose these data sets to things like QuickSight, where you can visualize this data. Again, within QuickSight, we have built a native integration with IoT analytics. Again, I'll show you more on the console later on when I demo the service. And also an integration with SageMaker. For those of you who are not familiar, SageMaker is a managed machine learning service. So it provides native integration with SageMaker, where we actually provide you, besides the the usual algorithms and notebooks which we make available on SageMaker, or you can bring your own algorithms and your own notebooks. We also provide, in the context of IoT analytics, we also provide some common templates, some common notebooks, such as predictive analytics, anomaly detection. I'll show you in today's demo. I'll show you one of such notebooks around anomaly detection later on. So just a very quick run through of these components. So channels, as I said, these are the entry points into IoT analytics. And you can collect data from multiple sources using APIs that we provide. And data can be in, again, different formats. You can have binary or JSON. And it is elastically scalable. Again, because it's a managed service, you won't have to actually worry about the underlying infrastructure provisioning. We manage that on your behalf, whether you use 10 devices or 10,000 devices or hundreds of thousands of devices. We scale all these underlying infrastructure underneath this managed service. In terms of the pipelines, so you can do a number of things. As I said, broadly, you can do filtering, you can do enrichment, and you can transform this data. So from filtering perspective, you can actually apply conditionally remove certain attributes, for example, or where you think you may have some outliers in this data. Incoming telemetry, you can apply some filtering mechanisms. You can also apply some transformation using simple mathematical and conditional statements. And shows an example of converting a temperature, but you can apply really any mathematical equation on the like simple mathematical operations on the incoming fields in your telemetry. From enrichment perspective, you can bring some additional data from things such as MQTT topic or device registry or device shadow. Okay, if you can think of examples like if you want to know with each of these incoming telemetry, if you want to correlate with which device is running on which firmware, and maybe if you have that information in your device registry, you can pull that information from registry to have that additional context around your incoming data. So, or you can use any other MQTT topic if you want, as well as device shadow. So device shadow is, if you're familiar with the IoT core, is essentially gives you a device state. So what was actually device's state when that data was coming through this device. So it can help you actually bring some additional context, as I said earlier. It also provides the ability to do custom processing. So you can actually build Lambda hooks, and you can call external APIs or bring, here's some examples of either geolocation or weather data or any additional context you want to bring from maybe your line of business systems that can help you add more context into that, into your pipeline. And you can also replicate these pipelines. So for example, you may have one pipeline already working. You can create a similar pipeline. You can try tweaking some of your filtering criterias or some of your transformations to see what effect it might have on your incoming data set. So you can very easily, without actually changing anything to, let's say, your production pipeline, you can run different kind of simulations if you want, by creating a version of your main pipelines. And the data store, as I said, it's optimized data store, managed data store for IoT use cases. It's immutable and it's fully managed. The data in the data store is partitioned by time, and it's really important, again, from an IoT use case perspective, where you want to actually run queries which are based on time series. You can retrieve data faster, and it also supports some. You can apply your own data retention policies as well. So if you choose to do so, you can apply some lifecycle, in the sense how old data you want to purge out of the database. So you can apply that as well. So data sets is, you create data set by using SQL queries. You can run these on ad hoc basis, or you can actually schedule them. And there's different time frames we support on this. So you can run it on a weekly basis, daily basis, or hourly basis. So if you've created a data set and you specify a schedule in a so when you on the console, you can choose it from the drop down, and it basically uses a cron kind of expression to apply on top of that, and it will automatically refresh that data set for you. Or you can run this on a ad hoc basis as well. You can download the data if you want from the console, just to see in a CSV format what you have in that data set, and or you can use other tools such as QuickSight and Jupyter Notebooks to exploit this data from a machine learning perspective. So as I said earlier, we provide a native integration with SageMaker. I think it'll make more sense when I show you this on the console. Maybe you can visually see how this is going to work. But it's again a very much a few clicks deployment from console. Once you do that, it will use SageMaker to either use an existing notebook if you have provision already, or you can create a new notebook directly from the IoT Analytics console. And these are some of the kind of templates we provide from a notebook's perspective for predictive maintenance, anomaly detection, forecasting, or you can build your own if you want, or bring your own as well. So in terms of before I move on to the demo, just maybe a few quick slides on the use cases. So, and these are some of the common use cases we're seeing, but there can be many more use cases that you can use it for analyzing this data. But in consumer IoT use cases, you can use this for collecting data from your devices, so you can understand how your devices are being used, what's the what device what sort of messages and history you're getting from these devices. You can also actually use it for collecting the customer behavior, in terms of how customers are interacting with your devices. So as you bring this data, you can apply a lot of that, bring a lot of intelligence based on the telemetry, as well as some of the contextual information around that you may have with your users or other business systems. You can use it to segment your customers and fleet based on the usage patterns, based on the adoption triggers. If you have a fleet of consumer devices, you can see, well, how many of these devices are used, how much by which users, how much of these devices are actually even activated, how often your customers are using it. So you can actually bring a lot of good insight from there. Also, from a maintenance point of view, you can look at things like how many over-the-air upgrades actually worked, or how many failed. So you can actually do some of the actual device state analytics as well, in terms of what's the current version of software or firmware they're running, how many software deployments failed. So you can do you can bring insight like that as well. In the industrial IoT use cases, again, with the integration with SageMaker and machine learning algorithms, you can bring some real-time contextualization of the how these devices are behaving in the real time, as well as do predictive maintenance or predictive analytics in terms of as you get this data into IoT Analytics, and you run these, you push this into these SageMaker machine learning models, you can start identifying the anomalies in your data sets, or where your devices may actually fail in near future. So you can do a lot of that analysis, again, powered by machine learning algorithms, machine learning models. Now, I wanted to bring this into context that where does IoT Analytics fit when we look at the overall IoT devices lifecycle. So we talked about Greengrass, and Greengrass can help you run the logic and around data, processing this data and locally on the device, as well as run machine learning models as well. So one of the features we have launched with Greengrass is Greengrass ML inference. So if you think of this as an ongoing loop, you can actually bring the data from your devices from when you're running Greengrass, or even when you're not running Greengrass, but you can then use IoT Analytics in combination with machine learning to really identify, if you're doing things like anomaly detection or predictive analytics using SageMaker, and from there you can run these models in the cloud. If, let's say, for example, you have applications where you can actually use these models in the cloud, but also you can actually push these models. You can train these models in the cloud, and obviously cloud is the ideal place to train your machine learning models, because that's where you have a scalable storage and scalable compute that you often need for training machine learning models. But once you have trained these models using Greengrass, you can actually push them onto the device. So where in certain use cases where you cannot be connected to the cloud or internet all the time, you can run these machine learning models on your devices itself. And then you can carry on with this loop. You can bring new data from your devices and retrain these models. So your model learns, the more data you have for your machine learning models, or the new data set you collect from your devices, the better your machine learning models will become over a period of time. And you can continue in this loop as you get more and more data from your devices. So before jumping to the demo, just to also very quickly mention that the service has now is generally available now from last week. We have some customers already using the service, as well as we have quite a wide partner ecosystem as well, partners who are providing services and solutions around IoT analytics and other AWS services as well. So at this point, let me jump onto my AWS console. So what I'll first show you is how to go about creating these components that we have seen on the slides, and then I have a pre-built demo which I'll show you as well, just to save some time on this demo today. So when you go into your AWS console, you'll notice that under Internet of Things, we have a few of these services, IoT Core, Analytics, etc. So let's just jump into IoT Analytics from here. So let me actually move into a different region. So as you see, it's at GA, it's available in these regions, North Virginia, Ohio, Oregon, and Ireland. So let's just move to Ireland, and maybe we can try and create something here. So as I said, first thing we want to do in IoT Analytics is create a channel. And channel, we can push data into this channel from IoT Core, or using APIs from any other sources like Kinesis, like S3. So when we create a channel, let's just call it, give it some name. And it gives us an option to, whether we want to leave the data there, or do we need to apply some retention policies. So you can choose to do that. Now, this is where when I was talking about it, natively integrates with IoT Core. So here I can specify the IoT Core topic, where I want this data to be ingested, where I want to actually pick this data from. Or another option is, or another option you have is when you go back to, if you have seen the IoT Core, let me open this in a new window. So within IoT Core, when you look at the rules engines, rule engine is essentially what helps you filter data and push data into other AWS IoT services. Now you can actually add actions to your rule engine. If you're familiar with the IoT Core, you would know that from IoT Core you can push incoming data into all these different services like DynamoDB, SQS, Kinesis, etc. Now you will notice you have another service available here for IoT Analytics. If you want to directly push data from incoming devices into an IoT channel. And at this point, you can select which channel you want to push data into. So you can specify that when you are setting up your IoT Core as well. So once you have a channel defined, the next thing you can do is then create a data store. So we can create a sample data store here. And that's it. It takes a couple clicks. Maybe something went here. Oh, I think I've probably used the same name here. But what we'll do is once we have a channel defined, once we have a webinar with this data store defined, Then we can start defining the pipeline. So pipeline is where you define your transformations. And in fact, I'll show you the existing one I have on the other prepaid demo. But here you will have to select a source. So a pipeline can have data from only one channel. So if you have multiple channels, you can select the one that you want to use as a source for this pipeline. Now at this point, because we're creating this from scratch, but if you had, let's say, an existing channel which was already pulling data from IoT devices, it will automatically try to infer the attributes from that incoming stream. Now, in this case, we don't have it's not picking up anything because we are not sending any data yet into that channel. But we can if we are starting from scratch, we can also define our attributes here, for example. So let's just maybe add a couple of them just to make it interesting. And once you have defined your attributes, you start adding your activities. And you can actually add these activities which are executed in a sequential order. So you can add, first activity, which could be, you can pick from, either you want to add. So you will also notice for each of these activities, it shows you what sort of category it fits in. So, when you want to add or remove an attribute, or add additional messages, to your attributes, or apply some calculations. So these are all examples of transformation you're applying to your attributes. So here's an example. If I want to apply some calculation, I can select my attribute here. That's the temperature, and maybe I want to convert this from Fahrenheit to Celsius, so I can apply this formula here. Anyway, I won't write everything here, but I hope you get an idea in terms of how you can then chain these steps. I can add further activities. So maybe when it comes into the pipeline, it goes through this calculation. I can add another step here, which could be around enriching this information. So if I want to bring some context from IoT core, I can specify which attribute I'm adding and which source I'm picking it from, in terms of the IoT registry, and so on and so forth. And I can keep adding multiple steps to this pipeline, if I'm, depending on how simple or complex your pipeline is. And once you define your pipeline, then the next step is to create a data set. So again, data set is, so what's going to happen is before this step, the data will come into the channel from IoT core or any other source. It will go through the pipeline that you have created, and the pipeline will then start pushing this data into the data store. And before we can do anything with that data which is coming into the data store, and data store is going to keep both the processed as well as the raw data within coming in from the pipeline. Data set is where where it really becomes usable. Whether you want to visualize or you want to create some integrate with some machine learning notebooks. So let's just look at this very quickly. So for creating a data set, you give again some ID. Let's say. And I need to select which data store I'm pulling this data set from. And after that, I can use SQL, standard SQL language. I can pull everything, or I can pick certain specific attributes or apply the where clause, all the standard SQL queries to then create a data set out of that. And then I can choose what frequency I want this data set to be refreshed at. So I can, as I said earlier on the presentation, you can run this on an ad hoc basis, or you can choose one of these available frequencies. So hourly is the the shortest window you can have for refreshing it, and that's about it. Then you will create a data set, and once you have a data set, sorry, just throwing some errors here. Once you have a data set, then you can actually visualize this. And I'll show this on the other demo, which I've already prepared for you, because I did. Otherwise, we would have to wait to make all this data available, to create some charts in the or run some machine learning models on that. So let me switch at this point to the one which I already have for you, or I think it's in a different region. So what I've here is, I was trying to create a scenario where I'm getting data, collecting data from a bunch of wind turbines. Before actually this webinar, I had already pushed some, randomly generated telemetry from my, it's a simple Python script which I was ingesting into IoT Core. And in my IoT Core, I had created a rule engine. In fact, very quickly show you. Sorry. So all this data was going into IoT Core, and we can in fact check if the latest data is coming in as well. If you just subscribe to a wildcard. Oh, sorry, I'm in a wrong region, I just realized. It's North Virginia. Okay, so this data is coming through from the device, and what we are doing here is from IoT Core using the rule engine, which I've created here, Turbine Analytics. I am picking everything from the topic, the MQTT topic, where I'm actually pushing this data from the simulated device and sending this to this IoT Analytics channel, which I've created in IoT Analytics service. So now let's look at the actual channel and pipeline that I have created beforehand. So this channel, a wind turbine channel, it's you can see it's active, and there's not much you will see on the console itself other than the ARN for this. But there's a simple pipeline I have created. So this channel is picking data from the IoT rule. In the pipeline, I have created very simple transformation, just two-step transformation, where I am removing an attribute which I did not want. So as you can see here, once it infers the attributes coming into the channel, it will show you basically what attributes are coming in. And then you can see these two transformations here. So I can edit this if I want. So calculate message here. I'm just applying the kind of the standard temperature conversion from Fahrenheit to centigrade and Celsius, and that's it really. Very simple pipeline, and this pipeline is then pushing data into a data store that I have created as well. And from this data store, and this is where it becomes interesting, I have created a data set as well. And this data set, now when you have data coming into a data set, it'll also give you a preview of just to see what is actually in there. And this is the SQL query I use to populate this this particular data set. And from here, I can actually also download the CSV. Let's say if I want to use it to do some offline analysis with that data, I can do that as well. And before I come to the notebooks, let me first show you the QuickSight integration. So when we go to QuickSight, one of the things you will notice that if you are familiar with QuickSight, it's one of our data visualization service. When you create new analysis, you can select or new data set. You have different sources you can select for your data. Your data can be in S3, or you can use Redshift, etc. One of the new things you will see here is AWS IoT Analytics. So actually, you can bring data, and once you do that, it'll give you an option to select well, which data set you want to bring this data from. So it is natively integrated with IoT Analytics, so you can directly pull data from the data sets you have created in Analytics. And in this example, what I've done is I have created a simple visualization here of this data coming in to the data set. In this case, I was just looking at, so I've created these 10 different turbines in my simulated data, which is, I think, still going through here. And here I'm trying to show average of the vibration frequency on these turbines. I've created another chart where I'm picking, minimum, oil level, through across the turbine ID. In this case, it's a more like on a data sort of time series representation of this data. In this case, I'm basically trying to build a different kind of dimension to that analytics. So again, if you're familiar with QuickSight, you can choose to build different kind of visualizations as long as you have the data coming into your data set. So the final thing I wanted to show you is, besides analytics, as I said, one of the real powerful things we have done is integration with SageMaker. Now, for those of you who are not familiar with SageMaker, let me give you a very quick 2 minutes quick tour of SageMaker, just to bring this into perspective. So here's the SageMaker service. As I said, SageMaker is a managed service where you can manage your end-to-end machine learning lifecycle from the notebook creation, where you can actually do some data wrangling and create your machine learning models. So in this case, I already have a notebook here. You can train using SageMaker as well. So you can run the training from the notebook, or you can do it from the console or through APIs. And within SageMaker, you can host these models as well. So if you want to use use these models through API calls, SageMaker can also host these models for you using the endpoint concept. So you can actually deploy the models and expose these endpoints for your applications to then infer from the model deployed in SageMaker. So what we have done in IoT Analytics is, so in this case, I already have created a notebook, but let's say if you did not have a notebook here, if you were starting fresh, you can just simply come here and create a new notebook. And when you create here, it gives you an option to choose a template. Now, these are the templates that we provide. These are the notebooks that we provide you to get started with creating these models. So whether you want to do anomaly detection and predictive maintenance, smart city congestion forecasting, and you can always use this as a starting point and then tweak for your own specific use cases, or you can create a new notebook if you wish to do so. In fact, these are the notebooks which are relevant in IoT use cases. But if you look at SageMaker, when you launch notebook in SageMaker, you see many other examples or the available notebooks as well. If you want to build different kind of models, so I can very quickly show you what the notebook experience looks like in SageMaker. So when you launch a notebook, again, you don't need to provision anything like an EC2 or anything. This is all built into the SageMaker service. So from here, from SageMaker, I just open my notebook instance, which I have created. And here I can see all the available algorithms within SageMaker. Or when you provision this from IoT Analytics, you'll see some additional notebooks which I've shown you on the console. So in this case, what I've done is, so when you provision this from IoT Analytics, you'll also see this additional category for IoT Analytics, and this is the template I chose. This is the notebook I chose when I provision this. So I can open this in the Jupyter, and from here it will pick up certain contextual information around. It already will have the data set information in here, so I won't have to actually tweak any of this. It knows when I provision this from IoT Analytics that which data set I was actually using when I provision this. There may be a few things you may have to tweak, but in most cases it should work in a out of the box manner. So this is the anomaly detection notebook, which uses a specific algorithm to predict to identify anomalies. It's based on PEWMA model, and without actually running through the entire notebook, just wanted to show you when I ran this earlier, just before the webinar. We'll spend a few minutes if I was to run it from the scratch. So I just ran it beforehand, and here's the kind of output you can see in terms of anomaly detection. And again, you have few variables to tweak here based on the sensitivity around the anomaly detection, and so you can still configure a lot of this yourself. So I think hopefully this gives you a good idea about how you can actually. Now this is a very simple example I've shared today, just to keep it simple and short. But depending on the simplicity or the complexity of your use cases, you can hopefully see what capabilities are available for you to start building your analytical workloads, IoT analytical workloads on AWS. So at this point, I would like to maybe take a pause, and maybe myself and my colleague Jan Matchner, who's also online, can help answer any further questions you may have. So,
yeah, thanks, Neeraj. So I would just want to highlight a few questions that came up in the middle, and I answered them already. So
okay.
There was one question regarding the difference between Kinesis Firehose and IoT Analytics. Actually, you get with AWS IoT Analytics, you get a bunch of things out of the box, whereas with Firehose, S3, Athena, and so on, you would need to build actually what AWS IoT offers out of the box. There's an additional input API. So if you want to redrive something from a different platform or whatever, from a different source, you don't need to drive it through AWS IoT Core. You can directly push it to AWS IoT Analytics. And there are at the moment no other service integrations. If you need other service integrations, let us know. And Neeraj, can you answer which notebook template you chose? I know it, but
sure.
just
Yeah, sure. So let me just show you if I, hopefully you managed to still see my screen. It was when you, now in this case it will show this, well, this is the name of the actual notebook name, but you will notice that when you created it for the first time, this is one of the templates which says anomaly detection in there. Let me see if I can show you in the other region very quickly. Sorry, my screen is hidden. So in this case, when we created so here, when you create a new one, you will find these are the available options. Again, over a period of time, we'll add probably more templates, but these are the ones. So the first one, this is the one I was using for anomaly detection. Okay. Hopefully that helps. Okay. So I think there's a question around, I assume you can't get minute, or is it a minute, I think, granularity out of the analytics platform. So at the moment, as I showed you, the most granular from a time frame perspective, I think your question is probably in the context of when we created the data set, like in terms of the frequency of refresh. So you're right, the schedule, the minimum you can do is an hour. Again, we will be hearing feedback from our customers in terms of if we find relevant use cases, we can obviously speak to our service teams. But yeah, that is the most granular you can get today. But at the same time, I think this probably addresses most common use cases around analytics as well. So we have other options. If you want to go absolutely real time today, then there are other approaches you can take as well. So yeah.
So maybe just answer one other question regarding pricing. So look at our website. Pricing is publicly available. You more or less are paying a price per processing, per data storage, and per execution. Especially data storage is quite low because it's quite similar to the S3 rate, or it's for the raw data, it is S3 rate because there are actually 2 data stores inside, and data processing is something like 20 cents per gigabyte. And then there's an additional cost per query. So depending on how much data needs to be crunched for your query, you need to pay for that.
I think I'm also seeing a question on are notebook features provided out of IoT Analytics. So yes, that's correct. So this is a feature. The notebook is actually a feature of our machine learning service, SageMaker. But within IoT Analytics, we have provided that integration. If you saw on the console, when you go under the notebooks, you can actually create notebooks directly from your the experience within IoT Analytics. So, but essentially, it's part of our machine learning service, SageMaker. Right.
Niraj, I think you answered already the question regarding minute intervals. So actually, you cannot, at the moment, you cannot run it every 5 minutes, a query.
Yeah. Yeah, that's correct. So as I said earlier, it's hourly at this point. Could we download this recording session? My understanding is yes. I think this will be available to watch later on, and along with the presentation I've shared with it as well. So. Okay, so I think maybe at this point we can, if you have any other questions, we'll be very happy to answer you offline. So at this point, maybe we can close the webinar. And once again, thank you very much, everyone, for joining. Really appreciate your time on this webinar. Thank you very much.